Part of the problem when you're working on vintage audio equipment is parts. Parts have become very difficult to try and track down. And that's par for the course. Anytime you get any vintage equipment, there's a good chance that, depending on what's wrong with it, you may not be able to get parts. And this is going to be one just like that. Let's see what the problem is. Today I received the TCD5M in for service. This one here looks like the plastic on the lid is coming apart. I'll have to glue that back in place, I guess, or stick it in place. It's actually held in place with double-sided tape is what it's originally done with, so maybe it'll stick back down. Let's see what the problem with this one is. Looks like the latch is broken on here. So, like this takes two D-size cells. Let me find a couple D cells and we'll see what it does. A couple of mismatched old batteries. I don't know how old this battery is, but it's ancient, an old President's Choice. And a Panasonic. This one's a carbon zinc. What a weight difference between the two of them as well. This is an alkaline. They both measure over 1.5 volts, so these batteries should be okay for this test. The batteries check okay. But there's no movement of the tape, no attempt for the motor to spin. So I guess we have to take this one apart, see what's happening with this one. First thing to check is the DC to DC converter, which is right here. Check to make sure that we are getting voltage off of it. Is what it does is it takes the 3 volts from the battery and it steps it up to the voltage required for the different circuits. In this case it's plus 9.5 and minus 9.5 volts. So with respect to ground, when I turn on the unit I should expect to see 3 volts here, and I should expect to see plus and minus 9 volts with respect to ground. So if I turn on the power, if we look at the meter, I hate these leads, we have 2.4 volts there, 9 volts, negative 9 volts is there. So there's our 9.5 volts negative and our positive 9 volts. 19 volts between the two polarities. I was looking at the printing here, but that was an arrow actually pointing down to this one for our negative. So we have voltage, but the motor is not turning. The motor is not attempting to turn either. This uses a DC servo motor. It could be a bad motor, it could be a bad drive IC. I hope it's not the drive IC because good luck trying to get one. Well, good luck trying to get a motor either. A motor like this would be pretty much unobtainable. We have our motor supply, this one here. I think that's the red and the white are the motor supply. Motor voltage across these terminals here to turn on the motor. See if there's any voltage trying to turn the motor itself. And there's none. We're going to lift the circuit board out and just see whether there's a problem with one of the switches that controls the power to the motor. I don't know where the problem is on this one, obviously, at this point. All I know for sure is that the DC to DC converter is working and the motor is not. Gotta check some voltages to the motor. I think this is the motor drive IC. This one here, our IC701. Let's see if there's any voltages when I turn on the power. Here's our servo amp, our servo control on this unit. So I'll try to illustrate how the servo works on this one. So on the flywheel, there's an FG detector. There's also a rotation detector. This is the frequency generator amplifier down here. And it picks up a pulse off of the flywheel, the capstan flywheel. Amplifies that and passes that on to the servo control, which is IC702, which is the one at the top edge of the board. IC702 has a comparator, sends a signal out through pin number, looks like pin 5. It's hard to read the schematic, it's really not a very good one. To the sample and hold and low pass filter and the current amplifier, which then drives the motor over here. So looks like Q701 and 702, 703 and 704, 704 being the field effect transistor. Coming from Q901 on the transistor board, 2SA and B, or 2SA861 over here. This is the servo amp power, which is fed directly with power from the, I think, right from the batteries on this case. Our motor power comes from this board over here. This is the transistor board. This is the supply of power for the motor. So let's check and see right now whether we've got any power heading over to the servo, because obviously if it's not getting any power, then it's not gonna work, obviously, right? So let's just clip our ground back on here and we'll measure and see if we've got any power on the collector. The emitter should have battery voltage on it. The collector is what sends power back to the motor. And we'll measure for voltages and see if there's any voltage on the transistor. So here we are measuring the emitter. And the emitter has 2.6 volts, that's from the battery. The collector has 0 and the base has 2.1. Interesting. We should have voltage on that collector. So let's measure the transistor and see if the transistor is open. It's PNP, so negative to the base and the emitter. That looks good. The transistor appears to be okay, measured in circuit. Could something else be causing this to not turn on? A closer look at the schematic. The base, looking for a pen or something. Will this highlighter work? The base here, my highlighter's not working. What else is new? This one here comes down. It's controlled by this transistor. When the voltage is dropped, it causes the transistor itself to go into more conduction. This transistor is actually what drives the motor. The bottom circuit here, if you look on the bottom one here, the bottom one actually comes up. It's what goes to the motor, which is also going back to the feedback circuit on this transistor. So this transistor here is what's going to lower the voltage to turn the motor speed up, and that's fed back through from over here. So we're back chasing electrons back to the drive IC again. The drive IC is right over here, and it's off of pin number 6. Unfortunately, I don't have a good print. I wish the print was better than it is, but it is what it is. This is what we deal with these days when you get these old units. People scan schematics and put them up, but a lot of times the quality of their scans aren't very good, and this is no exception. So I've gone back and I was able to look on the PDF and blow it up and get some voltages for this IC, the Servo here. And so pin 6 is my output. I should have about 2.2 volts DC on pin number 6. And we're just going to take a look at that. And I'm going to look and see if the sawtooth generator is working. Our amp is running. Okay. Pin number 8 is the, where are we here? Pin number 8 should have about 2.2 volts, as well as pin number 6. So pin number 8 is 2.3 volts. Pin number 6 has 0. Pin number 7 is the input, 9 volts. We're going to go down to pin number 1. Pin number 1 should have my sawtooth signal on it. And if I don't have a sawtooth on there, that IC is probably toast. So let's just take a look at pin number 1. I got my scope here. I'll show you guys the probe in a second here, but let me just measure it and see whether there's anything on pin number 1. I would explain why this thing's not working. This IC is cooked. No good. I'll show you guys the scope here. Look, it should have a sawtooth signal on it. It's got nothing. Okay, I'm just going to touch the end of the probe so you know that the probe is the scope is working. Okay, there's just my finger touching it. This is pin number 1. Nothing. Dead completely. There's no activity on this chip. Just the DC voltage. And that is why the motor is not working on this unit. IC 702, the CX069 is shot. That's what generates the voltage for the servo control. Basically what it does is there's a sawtooth waveform generators in here, and there's no signal. It gets sent over to the sample and hold where it's compared, and there's no signal coming out of this IC. The IC is shot. I remember changing some of these ICs way back in the day. It was a failure that happened once in a while on these and the DD6, the little Walkman Direct Drive 6. Used the same type of control circuit. I do remember changing some of these ICs going way back. Looks like that's what's failed on this one as well. So unfortunately, I'm going to say this one here is not economical to fix. Well, not only is it not economical to fix if you could get the IC, but just due to the age of this thing, this IC is not going to be obtainable.